Hello, everyone. My name is Erin Lester, and today I'm going to be presenting my influential study, The Split Brain in Man. So, a little bit of background information for you. The study was conducted by Michael Gazzaniga and his colleague Roger Wolcott Sperry, who was actually the first to study split brain patients about 15 years prior to this 1967 article that we're looking at today. So they were interested in how the separation of the hemispheres affects the mental capacities of the human brain after the brain splitting procedure. The brain splitting procedure consisted of cutting the corpus callosum, which is a bundle of nerve tissue that sits right in between the right and the left hemisphere. This was first done in animals such as cats and monkeys, and then was eventually done in humans to alleviate symptoms of epilepsy as seizures. Um, so a little bit more about this study is this article is a brief overview of about 5 years worth of studies done by the two of them. Um, After the procedure, they noticed that none of the patients had any noticeable change in their temperament, personality, or general intelligence. But they did notice that the patients tend to favor one side, the right side, over the left whenever they're doing day-to-day activities. Because they noticed this whenever a patient would brush up against something on their left side, they wouldn't acknowledge it or feel it. Or if they were to hold something in their left hand, they would often deny the presence of that object being in their hand. So there was two different tests done for the method section of this article. It was the visual stimulus and the tactile stimulus. It's important to note what hemisphere processes and perceives information from which side. So in terms of visual stimuli, the right visual field goes to the left hemisphere, and the left visual field sends information to the right hemisphere. Same thing for the tactile stimulus, is stimuli in the right hand is perceived by the left side of the brain, whereas stimuli in the left hand is perceived by the right side of the brain. So for the visual method, um, the patient was given a visual stimulus, which was a flash of an image or a word on a translucent screen for about a tenth of a second. They were then asked to call, um, they were then asked to give a verbal or nonverbal response to the stimuli. The tactile method used a tactile stimulus, which was an object that was placed in either the right or the left hand, and it was out of view of the patient. So then they were then asked for that verbal or nonverbal response as to which hand and what they believed that they were holding. The results came out to this. When asked for verbal cues, they found that the left hemisphere could easily respond with speech and writing, whereas the right hemisphere wasn't as clear and it had to rely on the guesses from the left hemisphere. When asked for nonverbal cues, they found that the patient was able to process information in the right hemisphere and then locate the object in their left hand. But they couldn't name this object because the tactile information was being sent to the right side or the right hemisphere, but the language abilities are located in the left hemisphere of the brain, resulting in them not being able to label or name what the object was in their hand. Why is this study important? Well, it shows that there are certain functions assigned to a specific hemisphere, and more specifically, that tactile information is sent to the right hemisphere, where the left hemisphere is superior in all things language. Another important takeaway from this set of studies is that when separated, the two hemispheres act as two separate areas of knowledge and consciousness, and that they're able to be independent and have their own set of emotions um, when shown as stimuli. Why is this study still relevant today? These are two examples, two articles that I found, one from 2015 and one from 2005, both of which are studies that were either influenced or simply would not have been able to be conducted without this initial study of the split brain in man. The first one is the consonance effect, and this was done by playing music in the patient's ear. They had a control group, and then they also had one patient with split brain syndrome. They played it in both ears, which is known as binaural, and then they also played it in one or the other, right or left, and this is known as dichotic. They found that whenever they did do this, that the patients with a split brain um, did not experience the consonance effect, where those without the split brain did. They found that the two hemispheres work independently in identifying the consonants. So thus, it only furthers the research or the what was found in the initial study. The second study that I want to bring up is that of the split brain reveals separate but equal self-recognition in two cerebral hemispheres. This study looked at self-recognition and other recognition. As you can see in the image to the right, it says that the right hemisphere is in charge of spatial recognition and facial recognition, when this study found that there's no evidence for hemispheric difference in ability to self-recognize. So they did this by showing the patient images of them distorted and also other people's images, and they were to distinguish who or if they could recognize the person, and they found that there was really no difference in those that were that had cut their corpus callosum. So this is a video that I wanted to show you. Um, it's a clip of Gazzaniga's one of his studies, and you show him talking and demonstrating that the left hemisphere's ability and tendency to make cause and effect interpretations of what it sees in the world.
This time, instead of naming the word, I want you to point to the word.
Again, Joe sees two words simultaneously. Bell goes to his non-speaking right brain. Music to his speaking left brain. When asked to point to a picture of what he saw, he chooses Bell. But when asked why,
Yeah, why'd you pick that one?
Music.
Music.
and when asked to explain,
It was music and bell, and it was a few minutes ago. Last time I heard any music was coming from the bells out here, banging away.
So the bell's
Yeah.
outside here.
So, but good enough answer to me.
what's extraordinary is that Joe's speaking left brain concocts a plausible story of why he pointed to Bell, even when some of the other pictures more obviously represent music. Gazzaniga believes this determination to find cause and effect, this desire to explain, is the left hemisphere's most marvelous property.
One of the unique things to the human brain is this need to interpret why two events occurred. What was the antecedent of this? What caused this? And if you can imagine that a species like us that has that little chip in its brain that asks those questions is going to survive rather well, because it's going to figure out more about the nature of the world than a species that doesn't have that.
This time, instead of naming the
Okay, I want to thank you for enjoying my presentation, and I hope you have a great day.